What's up, everyone? Welcome back. Patrick here. Moving on to the next quadratic equations word problem. So we have to find the dimensions of a right triangle if the longest leg and hypotenuse are consecutive odd integers and the shortest leg is 9 less than the hypotenuse. So let's start off with a diagram here. So we have a right triangle like this. And remember, the legs of a right triangle are the non-hypotenuse sides, basically the sides that are attached to the 90 degrees. This here is the hypotenuse, and notice that this here is the shorter leg, this here is the longer leg, and then we have the hypotenuse. And then we're told that the longest leg, this side, and the hypotenuse are consecutive odd integers. And remember, how do we show or represent consecutive odd integers? Well, we represent it as x and x plus 2. It doesn't matter if these are consecutive odd integers or even integers. We represent them like this because if they're odd integers, so for example like 5 and 7, they're going to have a difference of 2 between them. That's why we have this plus 2. But even if they're even integers, still the difference between those is 2 as well. So whether you're dealing with consecutive odd or even integers, that's how you would represent them. You could also do x and x minus 2, so you could represent the larger one as x and then the smaller one as x minus 2. Personally, I prefer to represent it as x and x plus 2, where x is going to be the lower of those consecutive odd integers. Now, if it was consecutive integers, it would just be x and x plus 1. There would be only a difference of 1 between them. Right, so that's how you represent it. Now, out of these two, this is the longer or the larger value, so that's obviously going to be the hypotenuse because it's the longest side, so this would be x. And then we're told that the shortest leg, this one here, is 9 less than the hypotenuse. So if we take the hypotenuse, subtract 9 like terms here, we get x minus 7. And now notice that we've represented all the sides with expressions, and we could throw these, we could relate them with the Pythagoras theorem. So basically x minus 7 squared plus x squared is equal to x plus 2 squared. So this would be x squared minus 14x plus 49 plus x squared is equal to x squared plus 4x plus 4, like that. So then these are like terms. And what I'm going to do is actually bring everything over to the left side, right? So we'll have 2x squared minus x squared. When this comes over, it becomes minus x squared. So we'd have x squared. Negative 14x minus 4x would give us negative 18x. And then 49 minus 4 would give us 45, like that. And then this actually factors smoothly. You could put in the quadratic formula as well if you want, but it does factor into those two factors, x minus 15 times x minus 3. And then from there, from those factors, we can get the solutions. So from this one, x is 15. From this one, x is 3. Now we got to check these according to the word problem. Notice that x equals 3 would not work out because notice what would the sides be? We'd have 3 over here. We'd have 5 over here, but then 3 minus 7 would give us a negative 4. And that right there does not make sense. According to the word problem, we can't have a negative side. So this one here, we would ignore. What about the 15? Well, this would be 15. That means this would be 17. And then this one would be 15 minus 7, which would give us 8, like that. Okay, and you could check these because 8 squared plus 15 squared would indeed give us 17 squared, right? Here we have 64. Here we would have 225. And then we would end up with, 289 over here. That's what 17 squared is. And then notice that this here is 289 as well. So left side would equal the right side. So the Pythagoras theorem holds with those values. Okay, and it also makes sense according to the words consecutive odd integers, 15 and 17. And then the shortest leg is 9 less than the hypotenuse. 17 minus 9 would give us that 8, right? So those end up being the dimensions of the triangle.